In this lecture, I'll show you how to implement the contribute function, the function that is called when someone wants to make a pledge to our fundraising campaign. Function contribute. This function is public and payable. It must be a payable function because when calling this function, an amount of way will be sent. Inside the function, we have some requirements. We must verify that now is less than deadline. This means that our fundraising campaign is still ongoing, so it hasn't ended. We also require that the amount sent is greater than the minimum contribution, so msg.value, the sent amount, is greater than or equal to minimum contribution. We also have this variable named number of contributors. We'll increment its value if this is the first contribution of our user, of our contributor. So if contributors of msg.sender is equal to 0, this means this is the first contribution of msg.sender of this user, then the number of contributors will be incremented. We need this test because we don't want to increment this value every time somebody sends Ether. We increment this value only if this is the first time that user sends to our campaign. We add the value sent to the value that this user has already sent. So maybe this is not the first contribution, this is the second. And I must add this value to the already existing value. So contributors of msg.sender plus equal to msg.value. And I'll add the msg.value to the raised amount, the total amount this campaign has raised. Raised amount plus equal to msg.value. We need this variable, the raised amount variable, because we must know at any moment what is the total amount that this campaign has raised. We can get the campaign balance using a function, but the campaign balance is a dynamic value. Maybe the admin spends some money and the balance has decreased. I want to see what is the total amount that this campaign has ever received. Now let's create a function that returns the contract balance. I want to see at any moment what is the contract balance. So function get balance. This function is public. It doesn't modify the blockchain, so view, and returns a new int value. We did it many times, so address of this is the current contract casted to an address, converted to an address, dot balance. Now let's test the contribute function. So I'll deploy the contract using the first account. The goal is 100 and the deadline will be in 10,000 seconds. The second account sends 40 way and the third account sends 50 way. The value will be sent by calling the contribute function. The contract balance is 90, and if I want to see the balance of these two addresses or the amount these addresses sent, I can copy the address and paste it here in the contributors mapping. So the first contributor sent 40 and the second contributor sent 50. And now the second contributor wants to send, let's say, 15 more way. the balance is 105, and this address has sent 55 way. So I added the last sent value to the previous sent value. This is why here I used the plus equal operator. And the raised amount is 105, is equal to the balance because nothing has been spent. We can say that our contribute function works well. Let's see how many contributors have sent to our fundraising campaign. So the number of contributors is 2, even if we have 3 transactions, because the second account sent 2 times. This is because I increment this variable only when that contributor sends for the first time. So if this contributor sends 60 more way, I don't increment this variable. The number of contributors remains 2. But if this account sends 77 way, the number of contributors is 3 because that was the first transaction for this account. We can say that our contribute function works as expected.